Hey y'all, in this video we're going to go over the answers and explain how to solve the questions on the X and Y component practice worksheet. So for questions 1 through 4, the worksheet has you determine the X and Y components for each of these vectors. So let's work through each of them. The first one, you have a 50-meter vector that's going at 25 degrees north or west. So your first step is going to, of course, be to draw it out. So to go 25 degrees north of west means your angle is going to touch the west axis. And it's going to be 25 degrees above that. And then the 50 meters of your magnitude is going to be what ends up being the hypotenuse of your triangle. So that's sketching it out. Now you want to, of course, turn that into a triangle. So we're going to enclose that 25 degrees by going over and then up to get our right triangle. Your X side, or your X component, is always the horizontal side of your triangle, and the Y is always the vertical side. Now you can use sine and cosine to solve for the X and Y components. So for the X side, our X vector here is touching our 25-degree angle, so that would be adjacent, and then the Y side of our triangle in this case is across from it or opposite of it. So we're going to use sine. So for X, it's going to be your hypotenuse, which is 50 times cosine of our angle of 25 degrees. When we type that in the calculator, we are going to end up getting 45.3, and our units are here was meters, so we're going to keep that meters. And then the last thing we want to add to this is whether we need to add a positive or negative symbol to it. So when we're going west or south, it's going to be a negative vector, okay? So in this case, our X vector is going to the west, so it is going to be negative. So the calculator doesn't give us the negative, but we're going to add that negative in front to tell us which way this X component is going, okay? Now for the Y vector, our Y was across, so it's going to be sine, so it's going to be a hypotenuse of 50, sine of 25. When you type that in the calculator, you're going to get 21.1 meters. And then the Y is headed north, so that's not west or south, so we're going to leave that as a positive number. All right. That's your answers for number 1. For number 2, we have a 10-meter vector that's going 40 degrees south of west. So again, our first step is to draw it out. So south of west means your angle is going to touch the west axis. So by 40 degrees, we're going to go below that. And then the 10 meters is your hypotenuse. Then, of course, again, you want to turn that into a triangle that encloses your angle. X is always the horizontal side, and Y is your vertical side of your triangle. Now, again, you can use sine and cosine to solve for those X and Y values. So for X, the X is adjacent. We know that because it's touching that 40 degrees. So X is going to be our hypotenuse of 10 times cosine of 40. And when we type that in the calculator, we are going to get 7.7. And now we want to look is X going east or west. In this case, X is pointing west. So we do want to make our X component negative to tell us that we are going west. All right. Then for the Y component, it's going to be our hypotenuse of 10. And this time we're going to use sine because it is opposite of our 40-degree angle. All right. When we type that in the calculator, we are going to get 6.4, and that is in meters still. And then we do want to once again add a negative in front of this because in this case the Y vector is headed south, so we want that negative there to tell us we're also headed south. All right, let's move on to numbers 3 and 4. All right, for 3 we are going 500 meters at 30 degrees south of east. So once again we are going to sketch that out. East of south means we're going to touch the south axis. And we're going to have a 30-degree mark here. Our hypotenuse is 500. And then for X, I'm getting ahead of myself. We need to turn that into a triangle first and go over or down and then over. And then have vertical side as Y, horizontal side as X. Now we can solve for the X value. This time, X is across or opposite of our angle. So we're going to use sine. So it'll be 500 for our hypotenuse, sine of 30 degrees. When we type that in the calculator, we get 250, and it is in meters still. And then we're going to leave that positive because x is headed in the east direction. Then for the y is adjacent to our 30-degree angle, so it's going to be 500 cosine 30. And that is going to equal 433 meters when we type that in the calculator, but we're going to make it negative because once again our y vector is headed south, so south is a negative. All right. Then for number 4, 15 meters west to south, we're going to of course sketch it out. West of south means you're going to touch the south axis, so 40 degrees, and then the 15 is our hypotenuse. And then we need to once again turn it into a triangle. Y is the vertical side, x is the horizontal side. So then for x, it is once again across from our angle, so we're going to use sine, so it's going to be 15 sine 40, and that is going to equal 9.6 in the calculator, as in meters, but it is going to be a negative because the x vector is headed west. And then for y, it's going to be 15 cosine 40, and that is going to equal 11.5 meters, but when we're also going to make that negative because x is headed west. All right. So again, we make the x and y is negative if they're headed south or west. Okay. All right, moving on to question 5. In this question, we are going to solve for the resultant vector using the x and y component vector. And this one, we're working with simple vectors that are just headed north, south, east, or west. All right. So we're going to use this chart to help us solve for that resultant vector. The first step we're going to do is sort each of these vectors into the respective columns. So just as a reminder, if it's headed east or west, it's going to be an x. And then if it's headed north or south, it's a y. All right. So for 42 meters north, that's going to be in the y column. And we're going to keep it positive because north is positive. All right. The next one, 70 meters west, is going to be in the x column, and we're going to make it negative because just like before on the previous questions, when it's headed west, we put a negative in front. Then for the third one, 30 meters east is going to be positive 30 in the x column. And then for 18 meters south is going to be a negative 18 in the y column. So again, all we've done so far is sort them into either the x or the y column based on if they're going east or west for x or north or south for y. If it's west or south, then you're going to put a negative in front of it because those negatives tell us we're going in the negative direction, or on a compass that'd be considered west or south. Okay. All right. So now your next step is to add up each column. So for the x column, our total here is negative 40, and for the y column, our total is negative 24. Okay. Now from here, you are going to use those totals to make a right triangle. So I always start by drawing the x vector first and then the y. Technically speaking, it doesn't officially matter, but just to make it easy, I would always just say to start with the y. So since it's a negative 40, that means we're going to go in the negative x direction. So we're going to go west and then 40. We no longer need this negative here because that negative was telling us which way to go. Now we have an arrow that's telling us which way we're going. So the job is done with that arrow. Okay. Then from the end of that one, we are going to go a positive 24. So we're going to go 24 up for the y direction. All right, you're going to again draw one after the other for this. Then your resultant vector is going to connect the two and give you that right triangle that you want. All right, and now it's solving just like a right triangle problem. So to find your magnitude, it's going to be Pythagorean theorem of 40 squared plus 24 squared equals r squared. All right, so you're going to solve all of that. You're ultimately going to end up with an r value of 46.6. So that is your magnitude. Your units up in the chart were in meters, so the units here are meters. Then to find your first part of your direction is the angle. So you're going to use inverse tan, and then the opposite side of 24 divided by your adjacent side of 40 will give you your angle. And when you type that in the calculator, you should end up with 31 degrees. All right. The last part of your direction, you need to know which way that 31 degrees is going. So if you put your vector on like a compass, we can see here that that degree is touching the west axis and it's going above that, so it'd be north of west. So your full final answer is going to be 46.6 meters going at 31 degrees north of west. And that is your final answer. Okay? All right, let's move on to the last one. All right, for the last question, question 6, this is putting all of the pieces together. You have two component vectors that we need that are going at angles, so we have to break them down into x and y components, like in the chart. So we're adding basically the steps we did in 1 through 4 to put them in the chart, and then from there, it's similar to question 5. So this is a long, tedious process, so just stay with me, okay? So let's first break down our component vector, the vectors given to us. And we'll start with the first one, of course. So it's going 40 meters at 65 degrees west of north. So it's going off like this. And its hypotenuse of this triangle is going to be 40, and your angle is 65 degrees. You're going to turn that into a right triangle. Your y is your vertical side. Your x is your horizontal. So for the x value, it's opposite of our angle, so we're going to use sine. So it's going to be 40 sine 65. The x, then when we solve for that, is going to equal 36.3. And we're going to put a negative in front of it because it is headed in the west direction. Right? For the y, it is adjacent, so we're going to use cosine. So it's going to be 40 cosine 65. And it's going to equal 16.9, and since that vector is headed north, we're going to leave that positive. So now we can go and put those numbers up in our chart of negative 36.3 and positive 16.9. Okay. Moving on to the next one. Our vector is going 55 meters at 30 degrees south of west, so we're below that line now. So our angle here is going to touch west and is 30 degrees. Our hypotenuse is 55, and then we want to enclose that into a triangle. And now for the x value, it is now adjacent, so we're going to use cosine. So it's going to be 55 cosine 30, and that is going to equal 47.6, and we want to make that negative because it is headed west. And then for the y value, it's going to be 55 sine 30. And then that is going to equal 27.5. And we also want to make that negative because it's headed south. So now we can put those in our chart of a negative 47.6 and negative 27.5. So far, all you've technically done is the same steps that you did in questions 1 through 4, okay? So now we're going to go similar to what we did in the last question, and we're now going to add up both of our columns. So in total, we get negative 83.9 in the x column, and then when we add up the y column, we're going to get negative 10.6. Okay. All right, from here, we're going to turn this into a right triangle. So we start by drawing our x vector. It's going at negative 83.9. So we're going to go, that negative tells me I'm going to go west. All right, and then for my y, at the end of that x vector, I'm going to draw a y vector, and that's going negative 10.6. So we're going to go down or south. And now I can draw my resultant vector. And the angle is the one where I started drawing. And now I can treat this like a right triangle problem. So we'd have 83.9 squared plus 10.6 squared equals r squared. When we work all of that out in the calculator, we're going to get a total, or an answer rather, of 84.6. Right? So that is our magnitude. And then for the degrees, we're going to use an inverse tan function. And our opposite side is 10.6. Our adjacent side is 83.9. And that gives us an answer for our degrees of 7.2. So this is a very narrow angle, right? So then the last thing we want to look at is the compass part, and we can see here that it is touching the west axis. So our final answer is going to be 84.6 meters at 7.2 degrees south of west, okay? So it's a lot of steps to get there, but it is doable, okay? But again, to recap the steps is to break down each of these vectors given to you just like you did in questions 1 through 4. Then you add up the columns. You'd use those totals to make your right triangle. So go the x direction, then the y direction. Then turn it into a right triangle. And then you use Pythagorean theorem in inverse tan to get your magnitude and your degrees. And then you just need to look at it to get the compass direction part. And that gives you your full and final answer. If you've got any questions, please let me know.